Alright, so this is going to be a video about the mean value theorem for integrals. If you remember, we had a mean value theorem for derivatives before. This is related to it, only though it's kind of the opposite because now it's for integrals. So the theorem states as this: if some function f is continuous on the closed interval from a to b, then a number c exists on that closed interval such that the definite integral from a to b of f of x with respect to x is equal to the function value at that c, that number c, times the difference between b and a. Now, what does this mean? Well, let's look at it graphically. I have a graphical proof here of this theorem. So I have a closed interval from a to b. Function f right here is this blue. And what this is stating that there's some value c such that if you find the f of c, right here, f of c, and you find the area of that box, so we have f of c times b minus a, which is this b minus a is this distance right here, times this height right here. So we have a base times a height for this rectangle in green. So if you multiply the height by this base right here, it's going to be equal to, at that special value c, it's going to be equal to if you just found the area of this function f under this curve. So if you found the area underneath this curve, it'd be the same thing as finding the area from a to b times, so just the distance from a to b times the height f of c. Okay, so basically there's some number c here that's equal to where whatever's below, so as you can see this red and green area right here, whatever's below this line right here, this height, and up here, these values would be equal. So you're including this value right here, but you're not including this value, so it kind of cancels itself out where it ends up being equal to the exact same area if you just found the antiderivative and subtracted the endpoints, as each of those are the inputs for the antiderivative. So this value here would be equal to this value at that letter c. Now if I moved c over here, the area here wouldn't be the same as the area over here. So there's that special number c that's right in the middle between these two. So you can just, this area and this area will kind of cancel each other out as if you were just finding the regular area using the antiderivatives, using the fundamental theorem of calculus. So if you have any questions about mean value theorem for integrals, let me know.